start. Okay. Assalamualaikum and good morning to everyone, especially for my respected lecturer and all to my fellow friends. Thank you for having me today, and thank you for giving me the opportunity to present my slide. So, my final year project is about chip and feature, and my name of project was manufacturing multi-holder wallet machine. And before I start, I would like to introduce myself first. So my name is Wan Muhammad Afif Azman, and I'm from EP47. So for introduction, chapter 1, I will explain this kind of topic, which is background of project, problem statement, objective, project description, and also project limitation. So we go to background of project first. So we involving a multi-holder wallet machine with organized design and compact to keep secure tool and accessible, and it's allow faster and easier to changing with using a simple locking system. So I could say it's suitable for all users, especially for us students. So for problem statement, there are 3 problem statements that we experience at our workshop. So firstly is lengthy process to change the cutting tool. So before this, we take too much time just to set up a catheter at the lathe machine. And then the second one is difficult to get a center point. So as we know, every time we change a cutting tool, we need to make sure that our cutting tool is aligned with the stock. So it's making harder to be done because of that. And then the last one is requires steel plate to get a center point. Steel plate, parallel bar, and seam is the same thing. So they have a lot of variety of size, and certain size is limited. And then sometimes other student will use at the other machine. So I could say that we rely on the parallel bar to set up a cutting tool. So that was the problem that we faced at our workshop. Next. So for objective, so our main objective is to design a multi-tool holder for the machine. So we improvise the existing tool post out there, and then the second objective is to analyze the time for cutting tool in the lathe machine. So before this, maybe we spend around 5 to 10 minutes to change the cutting tool at the lathe machine. Now with this product, we can reduce about 1 to 2 minutes, depends on individual skill. And then the last one is to align center point with steel stock without steel plate. So there we no need to compete or take turn with other students to use a parallel bar to set up catheter at the machine. So this is how my project looks like. Next. So the table shows description of product. So sorry. Material provided by college is mild steel. So I use a mild steel as our material, and the size is 245.15 millimeters by 170 millimeters. And the weight is quite heavy, which is 30 kilograms. And the feature was hexagon. And the application is adjust height of cutting tool and optimize time for the lathe machine. Okay. So for project limitation, actually our project only can be used at lathe machine, and the max number of cutting tool can be installed at one time is 6. Cannot be more than that, but can be less than 6. And the last one is range of cutting tool length in about 50 millimeters to 100 millimeters. So this is chapter 2 methodology. So I will explain about this kind of topic. Nak kena cakap satu. So this is master plan schedule Gantt chart. So it show our workflow for this year to making our project. So for project implementation, we involve a multi-tool holder for the machine. And I know this device is really important in industries such as manufacturing and engineering to set up a cutting tool. And it's making tasks more easier and more efficient, and also get a precise result. And then we studying existing information to understand what already out there. And the way we gathering data such as asking a few students about their feedback and opinion, and also we make a observation about with our previous experience at when we are going to change the catheter at the machine. So that's a project implementation. So this design concept, we have an accepted and rejected concept design. So this is accepted design, and this one is rejected. And the idea was being rejected because several important requirements are not fully met. That's the reason why this design was rejected by our lecturer. So as you can see, this is bill of material including a part number and description. So this is detailed drawing for top plate, and then this one for hexagon, this one for platform, pool, base, and last but not least, slate base. So assembly part we got a total part of 8 and including a standard part. Okay, next. So this is assembly video.
Okay, so today we are going to do assembly of our multi-tool holder.
Apa yang buncit?
Our base, slate base.
Yang buncit siapa ni?
Harris, Harris.
Just slide it on. Okay. Okay. After that, you will take your platform.
Buat video yang cantik.
Then I will align the screw. Over here. Okay, so we have a nut here, and then we lock it. Okay, now we are going to adjust our height of our nut screw. So now we are placing our cutting tool into our cutting tool holder. And then you will take a Allen key and tighten everything. Okay, next we're going to use the locking tool to lock it in. Okay? So you put it in, and you stay until it goes all the way down.
So that's the assembly video for our project. Okay. So for cell analysis, the task have been done by SolidWorks, and the result shows the hexagon was stable by using a normal pressure which is 100 Newton meter. Sorry. Okay, next. And same goes to factory of safety. Hexagon was stable. Right, next. So this is manufacturing process. I attached with drawing, manufacturing flowchart and manufacturing process of part. So as you can see, this one is a machining requirement to making this part, and got like operation description also. This for top plate, and then this for hexagon, pool, platform, base, last but not least, slate base. So this is Gantt chart for manufacturing process. So as you can see, this is Gantt chart for manufacturing process. Okay. Now we're talking about costing. So this is material costing. material cost. So the total was 72 ringgit and 74 cents. Okay, next. And this one is for machining cost, but the total hours is 56.6 hours, and the total cost for machining is 863 ringgit and 70 cents. But for grand total cost, for both, which is material cost and machining cost, is about 936 ringgit and 44 cents. It's quite expensive, yeah, I know. Okay, and then this is for chapter 3, finding analysis. Right. So, I made a test and troubleshoot for our project. So first, our hexagon cannot be locked properly because no stopper to block the movement of hexagon. So we decide to make a simple stopper with screw method. So as you can see in the red circle, the screw method that I mentioned before. Next. And then the second one is the base could not fit properly, and then it's making our project unstable. So we decide to remove a lead base so that our main base can fit on their platform, and we use welding applied to make sure connection, safe and stronger connection between two parts. And also we cut down the pull from 80 down to 15 millimeters to make it more stable. Next. And unfortunately, our top plate cannot be continued because we have like technical issues with machines. So we decide to remove the top plate. So once we remove the top plate, we use a method lock from the side rather than from the top. Okay. So this is chapter 4, which is the final. So for discussion, the manufacturing process of multi-tool holder start from material selection, and then dimensional accuracy and machining method is important to ensuring the effectiveness of this tool. And user feedback help us to refine the design to make it more ergonomic. And with ergonomic design, with a strong retaining rod or switching mechanism, will make it easier to use. And while more robust locking system for top plate and platform. So overall, I could say it's provide an effective and innovative solution to improve the workplace efficiency. And then for recommendation, so actually we have like a few things that we can improve with our project. So firstly, by using a CNC machining with high accuracy and check the measurement using a proper tool like a digital caliper and micrometer will help us to make sure that the size of each part is correct. And then by using a material like strong material and add heat treatment, help the part can be last longer. And this is where for design, making a handle or tool changing more comfortable. And last but not least, by improving the manufacturing process by using principle of lean manufacturing, will reduce time and save cost, but without lowering qualities of our project. So for conclusion, I could say the project successfully achieved their objective, and then I gained a lot of experience and knowledge from making this project. So by designing a multi-tool holder, by using a SolidWorks and AutoCAD to making 2D and 3D modeling, and including stress analysis, already achieved the first objective. And then for installation time that we recorded, the invention managed save time 20%, 20% of total times. which 7 to 10 minutes compared to before. But still, we need to what we call like depends on individual skill. And lastly, the third objective has been accomplished by eliminating the parallel bar. So I could say we no longer need to use a parallel bar on this process anymore. So I think my long term aim is to make this project suitable on industry, and then overall I think my project was successfully and worked well. So that's all from me, I think. So thank you.
Okay, good.